Hey guys, so in this video we're going to be talking about limit laws. So these are some of the limit laws, and just to summarize this top portion, it's just saying that f and g need to be defined on an interval near a, and there's no formal definition of near, it's just there needs to be an interval in which a is contained for which all of the points of the f and g need to be defined, but they don't need to be defined at a. They can or they can't, it doesn't matter. And then L is the value of the limit as x approaches a of f of x, and M is the limit as x approaches a of g of x, and that's M. So C is a constant, so the value of C doesn't change, and both of these limits need to be defined for these laws. So if you're adding two functions in the limit of those functions as x approaches a is equal to the limit of those individual ones. Same for the difference. If you multiply a limit by a constant, you can just pull the constant out and take the limit of that function. You can multiply limits, and the limit of the product of two functions is equal to the product of the two limits. And the quotient rule, it's just saying if you divide them, they should be the same, but the bottom cannot be 0, and that's important to note. Same for if you take something to the power, or if you take something to the root. So this is our first practice problem. So the limit as x approaches 3 of ln of x plus 3 of f of x. And we don't know the function, what f of x actually is, but we're given that the limit as x approaches 3 of f of x is equal to 5. So what we can do here is use the sum law, so we can split these two parts and take the limit as x approaches 3 of each of those parts. And then since we know that ln of x is a continuous function, we can just evaluate that immediately, because as we went over, the limit as x approaches a value in a continuous function is equal to the value of that function at the point. And we can also use the constant law. If you multiply a limit by a constant, you just pull it out. And then we know what each of these parts is, so as we said before, we can just plug in 3 here to get that. Then we were given the value of this over here, so we get this. So this comes from here and this comes from here, and then we just multiply this, and this is our final number. Then this is a second problem. So this is a rational function, and to solve this problem, we can use the division rule, but we have to remember that the condition for the division rule is that the limit as x approaches the value of the bottom cannot be 0. And since this is a polynomial, we know that it's continuous, and because it's continuous, it must be it's continuous at all points, and that way to find the limit, we can just plug in the number directly. So let's do that. We substitute 2, then we simplify it further, and it's 50. So the value is not equal to 0. So that means we can use the division rule here. So we take the limit as x approaches 2 of the top and divide that by the limit as x approaches 2 of the bottom. Then we can simplify that, because both of these are polynomials. They must be continuous on all numbers, all real numbers. So we just plug in the number as we always have, and we get this. We just simplify it, and then we get 4 over 25. Now this is our third problem. The limit as x approaches 0 of 1 over x plus x squared. So if to do this, we can use the sum law, right? So we have the limit as x approaches 0 of 1 over x plus the limit as x approaches 0 of x squared. But if we look at the function 1 over x, you'll realize that the limit as x approaches 0 of 1 over x does not exist. As the value gets really close to 0, from the right side, it goes to infinity, it goes to positive infinity, right? But if we look from the left-hand side, it goes down, as it approaches 0, it keeps going down, and it goes to negative infinity. And since the left-hand side and the right-hand side, they don't agree on a certain point, the limit does not exist. Because remember, for the limit to exist, the limit as it approaches that value from the left side must be equal to the limit it approaches from the right-hand side. And since this does not exist, it doesn't matter what this is. The entire limit does not exist then. So we get that the limit this does not exist. And now let's take this function and let's try to solve this. So as a reminder, this means the limit as x approaches 0 from the right-hand side. So we can use the sum law again, and note there should be plus signs here. And if we do that, we look as the limit as x approaches 0 from the right-hand side of 1 over x, it goes to positive infinity, right? And the limit as x approaches 0 of x squared, and this is a polynomial, so it has to be continuous, and that way we can just plug the value directly in. So we get 0 squared, which is 0. So we have infinity plus 0, and infinity plus 0 is going to be infinity. So those are all the limit laws, and these are really helpful when solving limits. You can break apart functions into smaller functions, and if we have to use algebraic manipulation, it gets really easy to just focus on one part rather than solving a big limit. So if you guys have any questions, put them down below, and thanks for watching.